closing a vulnerability ticket does not mean the vulnerability is fixed. It might mean someone attached a screenshot. It might mean the ticket owner said patched. It might mean the scanner has not run again yet, or it might mean the evidence is real, complete, and ready for audit. That difference matters. So in this video, I am building an AI agent workflow that verifies remediation evidence before a vulnerability ticket gets closed, not auto close. Verify package flag weak proof and route the closure decision to a human. Here is where a lot of vulnerability programs quietly break. The team creates a remediation ticket, engineering does the work. Then someone attaches evidence. Maybe it is a screenshot, maybe it is a patch note, maybe it is a scanner export, maybe it is just a comment that says fixed. But the security team still has to answer a few hard questions. Was the right asset fixed? Was the right vulnerability fixed? Was the fix validated after the change? Does the evidence match the closure criteria? Is the scanner result current enough to trust? And if an auditor asks later, can we explain why this ticket was closed? If the answer is no, the ticket is not really closed, it is just hidden. The agent starts with the remediation ticket and the evidence attached to it. Then it builds a verification packet. First, it reads the original finding CVE affected asset, package scanner plugin severity first seen, due date, required closure evidence. Second, it reads the submitted proof screenshots, patch versions, change records, scanner results, owner comments, pull requests, or deployment notes. Third, it checks whether the evidence actually matches the requirement. If the ticket required a clean scanner result, a screenshot of a patch window is not enough. If the ticket required a version upgrade, the agent checks whether the submitted version is actually the fixed version. If the finding was on a production API server, the evidence needs to point to that same system, not a different host name. Here is a simple example. The original finding says OpenSSL is vulnerable on an internet-facing API server. The closure requirement says provide scanner evidence showing the CVE is no longer detected, or provide approved compensating control evidence with reviewer sign-off. Engineering attaches a screenshot that says OpenSSL updated. That might be useful, but it does not fully prove closure. The agent should flag it as incomplete and ask for a fresh scan result, package inventory proof, or approved exception evidence. Now compare that with a stronger packet, updated package version, change ticket, fresh scanner result, asset hostname match, timestamp after the remediation window. That is much closer to closure, ready evidence. Here are the checks I would give the agent. Does the asset match? Does the vulnerability match? Is the evidence newer than the remediation action? Does the package or configuration version prove the fix? Does the scanner results show the finding is gone? If the issue is accepted risk, is there an exception ID, expiration date, and approval owner? If the issue is mitigated, is the compensating control specific enough? And most important, is there enough evidence for another reviewer to understand this decision later? The agent should not just say yes or no. It should produce a closure recommendation ready to close. Needs more evidence, needs retest, possible wrong asset, possible duplicate exception required, or escalate to human reviewer. Then it should summarize why. That summary is the valuable part. It turns messy proof into a reviewable decision packet. This is the control that keeps the workflow safe. The agent does not close the ticket by itself. It prepares the evidence review. Vulnerability analyst looks at the packet. They approve closure, request more proof, send it back for retest, or escalate it. That keeps accountability with the security team while still removing a lot of repetitive review work. This is also where security automation becomes more mature. Beginner workflow creates tickets. A stronger workflow tracks whether the work actually finished. Production workflow keeps evidence, decisions, approvals, and audit history together. That is the difference between automation that looks impressive and automation that survives real world review. If you are building a cybersecurity portfolio project, this is a a strong one. It shows that you understand remediation, evidence quality, auditability, exception handling, and human approval gates. And the point is simple. A closed ticket is not proof. Good evidence is proof, and an AI agent can help verify that evidence faster as long as the final closure decision stays with a human reviewer. If you are finding this content useful, please subscribe, like, and comment